So if we go 9 miles west and 9 square root of 3 miles north, that would put us over here in quadrant 2. So going west, so 9 miles west, and then our 9 square root of 3 miles north, we're going to be up here. So I'm going to draw in my triangle, and so I know that this is 9 square root of 3. Okay. So what we are trying to accomplish here is we are going to take those rectangular points and put them back in our polar. So remember, so right now we're in XY, but we want to go to our radius and our theta. So can we find radius given this information right now? Okay, so do that for me real quick, please. So you ended up with an 18 for your radius. How did you find your radius? Pythagorean theorem. Okay, so over here, what did we do? We found radius by using Pythagorean theorem. Oops. Okay. All right. And that gave us our radius. Now what we need to do is we need to find our theta. So we got our radius, so I'll just put that up here with our ordered pair. Our radius is 18. Now we're going to find theta. Okay. So what we're going to do is we have our reference triangle already up here. We are going to find our alpha. We're going to find our alpha by using our tangent. So let's do tangent of, and we'll do inverse, right, because we are finding an angle measure. Tangent, what would be the ratio there? What over what?
Sine over cosine.
Give me the sides. 9 square root of 3 over the negative 9. Okay. Now, so actually those 9s would cancel. Saves us this little bit of work from having to do. So we'd have the negative square root of 3. All right, so go to your calculators, put that in. All right, so you should have gotten a negative 60. Remember, however, that reference angles are positive. So we're going to go with our reference angle of alpha being 60 degrees.
Wait, what did we just do?
We found the angle. Yes. Yes. My.
We have to use tangent?
Yes, we're going to use tangent on these. Because if we don't, if we use our tangent, we can get a pattern going. Otherwise, sometimes your cosine. Remember, since we're doing inverses, you remember that we're limited with our tangent and sine. Remember, sine and tangent are limited between negative pi over 2 and pi over 2. And cosine is limited from 0 to 180. Okay, so what we're going to do is we're going to take the tangent and we're going to make our adjustments according to what quadrant we are in. So we're in quadrant 2, and we find that to be 60 for our reference angle. And then now we want to find what our theta is. So we get our reference angle to be 60, but remember what we're trying to find is theta. Remember, your theta starts here and goes to the terminal side. That was our terminal side, the radius. So now we need to find what theta is. So how would we do that? 180 minus. So we're going to take our reference angle and we're going to subtract that from 180, and that would give us what for theta? That would give us our theta to be 120. So that would go up here. So we'd have 18. I'll put it over here where we can see it a little better. So we end up having for our polar coordinates, we end up with 18 and 120 degrees. Now remember, there's basically 4 ways to write this. Right? We could have negatives, negative radius, we could have negative angle, but this is the one we will choose. So then the second step, so we have our two steps. So then our second step was to find our theta. Okay, and how did we find theta? Is we used inverse tangent. Okay, which is basically what, y over x, or opposite over adjacent. And then that will give us our, and then once you find that, according to your quadrant, make your adjustments. So we'll say make adjustment. So your adjustments will be like in this one, since we were in quadrant 2, we subtracted the alpha from 180. What would we do if we were in quadrant 3? What would we do? Do you remember what we do in quadrant 3? So if our terminal side, let's say this is our terminal side right here, my pen. Let's draw. So let's say that's my terminal side now right here. So my alpha would go from, so if we had our terminal in quadrant 3, our theta would go from here to here, right? So how would we adjust? So if we drew in our reference triangle right here, this would be our reference angle, how would we figure out what theta was? So to find our radius and our theta, so remember we have hit second apse to go into our angle. This time you're going to go down to your 5. So go down to 5. Hit enter. Put in your ordered pair, our ordered pair of -3, 3. So -3, comma 3. Okay, that gives you a 4.24. What's after the 4? Let's do 4.24. Yeah, let's do 2. Let's go back in.
What?
What is he right?
What? Being dyslexic. 4.24. Okay, how about that? Okay, let's do it again. So let's go back in. So second apse to get to our angle. This time we're going to do theta. You can see that theta is 6. Let's go down to theta. Hit enter again. And then again, put in your -3, comma 3. Okay, and that gives us 135. Okay, so there's your ordered pair written out, the 4.24, comma 135.